Welcome to Module 3, Design Guidelines. As you know, every great part starts with a great design, and a design must be dictated by the process to be used. In our case, with metal filaments like Ultrafuse 316L, shrinkage. Shrinkage is a differentiator from a typical FFF process. As we can see here in these examples that in the Z-axis, 20% shrinkage, right? And in the X and Y axis, 16% on average. So this part would need to be scaled up by 120% in X and Y and 126% in Z during the slicing process. So it's always important to remember to do that during the slicing process. Then when you're done, the part comes down to the actual part you want to see right here. One critical aspect of design is maximum part size. Now we've found in extensive training and testing is that about 60 millimeters cube is really the sweet spot. And that's just to give you a perspective, and that's your green part before shrinkage. This is about 64, 65 in diameter, and probably about 40 in Z. Now, again, this is a sweet spot because it's flat, it has very little overhangs, and those overhangs have been compensated with design. At the same time, this isn't a limitation. This is how we can get you the most success early on. Of course, we go bigger, and we go print bigger all the time. But this design guide is meant for a new user that wants to have the smoothest process as possible when starting to use our technology. And that translates after shrinkage of about this size. So again, getting in that methodology, that thinking of having to think of where the part wants to be, where it needs to be for printing. Now, again, for max size, it's not a limitation. We're going to show you parts that break these rules, right? Because these are suggestions, not hard, fast rules. Now, this part was 220 millimeters in Z in printing, way above what we're recommending. And, unfortunately, we got to learn. That's the result. I like to call that one. That one becomes modern art. This is why brown part stability is important. That's why we offer simulations. That's why we want to cut down the amount of iterations it takes to get through the part. So your first try, not so sure. Moving on, we're getting closer. We're finding out that there's delamination in parts like that, which we're going to talk about in more detail, but to kind of give you a perspective. It's our goal to reduce those iterations, to reduce the time and the frustration you might have when trying to realize your part. What we want to do is get you to your final part as soon as possible. Okay, when selecting the size of your part, you need to be aware that flatter parts with less overhangs or things like that are going to be more stable. So if you want to get bigger than that 60 millimeters and show more success, we would see printing maybe 145 by 145 in the XY, but only down to say 50 or 60 in the Z to prevent any kind of collapse or issues there. Now, if you have more monolithic part, you'd probably keep it into that 60 millimeters cube, or maybe at the very most 100 millimeters cube. Now, again, I gotta reiterate that is the green part size before shrinkage. One important aspect of part design is height to width ratio. And normally we like to stick within about 3:1 height to width. And you can see, why do we ask about that? The taller and thinner part we're gonna get can tend toward distortion or leaning, as we did in the King here. This has been cut in half. And you can see in this version, it started to tilt slightly over to the side, and you'll start to get distortion. And other parts like this, we can see again where you have too much mass on the top and not enough thickness on the body of the part, it'll begin to lean down through the viscosity of the material during the sintering temperature. Another critical aspect of design is unsupported walls. Generally, our rule of thumb is around 6:1 to maintain structural stability during the debinding and sintering process. And another situation that can happen is distortion during the debinding and sintering process. You can see in this case, we call these the twisty towers, where the walls were actually too thin and our print strategy was such that it twisted after debinding and sintering. These were printed and looked fine. Out of the oven, we made this so we could show how it could distort during the heat. Now, by changing our printing conditions, by matching the extrusion width and the amount of outlines to it, we're able to remove that effect and therefore show how to prevent this kind of distortion in debinding and sintering. Another important design criteria is unsupported holes. Now, generally we want to stay under 8 millimeters in diameter without supports. And when in doubt, go ahead and support it, knowing that you can later go back and cut or mill those parts after they're done being sintered. Vertical holes are less of an issue. That's more of a design constraint for the part you actually need and less of a concern during the layer by layer building process. One very critical and luckily very easy to fix is ensuring the part is perfectly flat on the bottom. Now, oftentimes when printing, it'll start to warp up or some things like that, and it's important to make sure that part is flat on the bottom. If it's not flat, it can kind of tilt. And then when it gets in the sintering process, it can exaggerate with the viscosity material. And you can see in this, one of our queen figures, we allowed it to warp in the printing process and then sintered it to show us an example of how much lean you can get even with a big part where we have a nice big support and the height to width ratio is okay, but still we're having that effect. So this is easily remedied. You can use sandpaper or milling or cutting, but just sand the bottom of that part until it's perfectly flat to prevent this leaning tower effect. Another critical aspect of printing with FFF is the need for supports. As we talked about, it's a layer by layer process, and each one of those consecutive layers needs something to adhere to and stick to, otherwise it can warp off the bed. In this situation, or as our rule of thumb is, under a 45-degree angle, we want to use supports. And this is pretty much normal for most FFF processes. But because we have the constraints of debinding and sintering and brown part stability, we want to be even more conservative. So I would say definitely 45 degrees, and when in doubt, support it more. And that's another reason why we have the orientation simulation and other software provided by our services group to help us really tune in our need for supports.